Welcome to our new podcast series called In the Mix. I am Wynn Darden. I'm the business manager for the Lumiflon FEVE fluoropolymer resins. The podcasts are all about choosing the right coating solutions, where we discuss with industry experts what influences their decision-making processes when it comes to specifying and using coatings. We'll delve into how experts develop their strategic planning approach to current structural and future market demands. Today we're talking with Mark Hearn, Technical Sales Director for Unova Paint Products based in Reading, England. Unova is committed to enabling coating specialists and tradespeople bring out the best of their craft with innovative, premium quality paint and equipment. In 2022, Unova was named Trusted Partner for distribution and manufacturing of A&I Coatings, Vitreflon FEVE-based coatings for the UK and Europe. Welcome, Mark. Thank you for sitting down with us. Why don't you tell me a little more about your company?
Yeah, sure. Thanks, Wynn. Appreciate this opportunity to join this session. So I'm Mark Hearn from a paint innovation company called Unova. I'm one of the founders of the company, which has been involved in the supply of specialist paint products since 1995, so coming on nearly 30 years now. Over that period of time, in the last 30 years, we set out as a distributor for a global paint manufacturer called Jotun, and then over the course of time, we've formulated our own range of products to meet various demands that we've identified in the marketplace, and hence we come over as a paint innovation company. And as you suggest, we've fairly recently come across the fluoropolymer paint technology. And we feel that certainly the innovation around fluoropolymer aligns with our passion and direction of Unova. And we're pleased to be introducing this technology in the UK.
We've been talking to A&I Coatings for quite a while. They've been in the FEVE coating business for a number of years. And how do you view these fluoropolymer materials as a coating solution in the UK?
Yeah, well, I think to appreciate the solution, we need to kind of understand the problem. And the problem, as we identify it here in the UK, is that traditional top coats, they just fail very, very quickly. Polyurethane, which is the kind of typical traditional top coat that's used in this region, it deteriorates very quickly under exposure to UV. So as exposed to the UV, it slowly erodes, and you get that typical discoloration and fading and chalking that's associated with that. And with that erosion, you then get the onset of corrosion, where you've got the vulnerable elements of a structure, whether that's the weld seams or the bolt heads. That UV attack erodes the coating back to the primers. The primers become exposed. They don't have any UV protection at all. So it's not long before you've got this corrosion setting in that's working underneath the paint film, and ultimately the structure becomes weakened, and repairs become expensive and very necessary in view of that structure being maintained. We were privy to some results of a survey that was conducted, actually, which kind of articulate the problems in real life. And this was a survey that went out to bridge owners, bridge designers, engineers, pretty much anyone in the bridge space. And one of the questions on that survey was relating to the key issues experienced in the past 5 years. And 90% of those who were filling out the survey chose that deterioration of corrosion protection systems was a key issue. And the other thing that came out of it is that the highest annual cost element for bridge maintenance was actually around the painting. So I think there we see the problem, and nobody's got to go very far in the UK, given that there's over 70,000 bridges in the UK. You haven't got to go very far to see the effects of UV on a bridge, and the discoloration, the fading, the corrosion that's setting in, the sorry sight that comes as a result of traditional paint exposed to the elements. So you ask about the coating solution in the UK, and we're very passionate. We firmly believe that fluoropolymer is going to make a huge difference in terms of how often a structure has to be repainted. You're looking at a life expectancy at least 3 times the length of a traditional paint system, just purely because you don't have that same issue with the UV attacking, or at least the UV will not have the same eroding impact on a fluoropolymer that it has on the polyurethane.
Right. And of course, the longer the top coat stays intact, not only the appearance will remain over a 60-year period, but also the corrosion protection supplied by that top coat will also remain for that 60-year period.
Exactly. I mean, there's been a lot of work over the years on the generic type of primers that are used to achieve the levels of anti corrosion that are needed. Um, but it would appear that in existing anti corrosion paint systems, the kind of weak link in the chain is that polyurethane. So, as you rightly say, the fluoropolymer is protecting that outer line of defence, enabling the surface to look to maintain its colour and gloss for a good long time, but also enabling all those layers of primer and undercoat to function to their maximum capacity within their anti-corrosive performance.
And there's quite a life cycle cost savings then for the bridge owner. Usually going to be some road agency or rail agency.
Yes, absolutely, and that's a massive lever. As much as something looking nice and pretty for a long time is very attractive, but there's that huge financial benefit. I mean, typically the entities that are responsible for the maintenance of the bridge structures are running on a fairly tight budget. If that budget can be used effectively, then you say that the repainting times are pushed out much further.
Right. So you're talking probably 2 repainting cycles with a polyurethane that you're avoiding by using the fluoropolymer.
Yes, exactly. I mean, the typical life of a bridge, the design life these days is around about 120 years. And a conventional paint system, you'd be looking at a reapplication between 20 and 25 years, which means the structure could be painted 6 times during its life,
Mm-hmm. Right.
as opposed to a fluoropolymer at just twice.
The focus has been on bridges. We agree with you. We think that bridge market over here in the U.S. is kind of an untapped market over here. That bridge industry is very conservative about using new products that come out. They're not going to put a new paint on unless they're convinced there's a great benefit to them. We have hundreds of thousands of bridges here in the U.S. and they're facing the same situation you face. The life of the bridge may be 100 years. They want to go out as far as they can into that cycle without having to repaint the bridge because that's where the benefit comes into them. Another trend here in the U.S. is that, say, the original life of a bridge is 100 years or 120 years. Well, some structures have come into that end of life, basically, right, when they were supposed to be replaced. What is happening is the budgets of a lot of these departments of transportation or bridge agencies and things like that, they can't afford to build a new bridge. The Bay Bridge in San Francisco was supposed to be $1 billion, the new Bay Bridge, and it came in at 4 or 5 billion, and it took them 3 years longer to finish it than they thought they were going to. So I think the same dynamics probably apply there in the bridge market as well.
Yeah, well, I think what you find on a when you look at a maintenance project for a bridge, it's so much more than just the cost of the materials. is, I guess, why we've targeted the bridge market is because of the difficulties associated with access. Not only access, but typically these structures are over a river or a estuary or something of that nature, and you've not only got the access, but you've got, I mean, right from the start of a maintenance project, you've got the feasibility and project evaluation, you've got all the consultation, the legal risks and the insurance, the, I don't know, traffic management, encapsulation, waste disposal. The list goes on, which makes the cost of the fluoropolymer material insignificant, really, to the cost of the project. And of course, frequency with which all those costs are incurred are reduced just because of the reduction in the number of actual repaints on that structure. But the same goes for any structure that's difficult to access. Um, it might be some kind of architectural structure or even facades and that sort of thing. There's huge scope for growth in the use of this material beyond bridges. That's for certain.
One of the environmental impact measures that's becoming more common there is carbon emissions. Have you been able to use that as a selling point for the application of the FEVE coatings on bridges?
Yeah, well, carbon is a significant consideration, and rightly so. Um, Becoming carbon net zero by 2030. I guess the dates will be pushed out as things are maybe not achieved as quickly as hoped. But we certainly feel that fluoropolymer it would be a very good contributor to anyone who's seriously trying to reduce carbon, just because of the fact there's less everything. There's less repaints, which means less paint, of course, and less manufacturing, less transportation, less waste management, less energy. Um, the use of fluoropolymer is most certainly going to result in the reduction of carbon. One of the challenging things to address is that a lot of this carbon consideration seems to revolve around EPDs, for instance. So, the importance of having an environmental product declaration for your product, which is very useful to a degree. But the reality is that an EPD for fluoropolymer won't be an awful lot different to an EPD for a polyurethane, because it's just purely looking at the production process and the materials from cradle to gate. Whereas really the consideration needs to be is that whole life cycle, the whole life carbon element, um, which really is something that needs to be evaluated as an LCA, or life cycle analysis. Um, and the data around that is obviously very, very site specific. So, as much as fluoropolymer will reduce the amount of carbon on an asset, to actually quantify that um, needs the LCA kind of analysis, which is obviously a longer, drawn out, more expensive analysis that then gives you that literal carbon saving. The only thing we can assure the designers and engineers is that there will be a significant reduction in the use of fluoropolymer.
Right. Okay. Yeah. Actually, years before the carbon analysis, LCA and EPD, there's a guy named Stuart Brand who founded the Whole Earth catalog back in the early 1970s, and one of his basic rules was uh, if you want something that's more environmentally friendly, make it last longer. And I think we're really hitting that with the Lumiflon coatings with the fluoropolymer. Yeah. What type of market trends are you looking at, short term and then long term with that?
Yeah, well, there's definitely a steady increase in the short time that we've been promoting the technology in the UK. I think there's been about 40 bridge projects that have been supplied now in varying scales. Yeah, so getting some good track record here in the UK. The 40 or so bridges already supplied cover a very wide range, or cover a range of projects from new build through to maintenance. For the maintenance, we're applying or supplying surface tolerant epoxies, and for the new build, typically we're supplying a zinc rich. So there's a kind of maintenance paint system and a new works paint system, both incorporating the use of the fluoropolymer top coat. So we've got projects that we've supplied right from the south coast right up to the top of Scotland. The most significant bridge that we've supplied to date would be the Blackfriars Bridge in central London. The previous coating was only 20 years old, and the London Borough Council responsible for that bridge asset were concerned not to be reapplying the same product again to get the same results. So for them, there was very little risk involved in putting this new technology to the test, and it's certainly been an excellent project for us to be part of. And then moving up through the country, a combination of pedestrian bridges for highways, pedestrian bridges over the Network Rail infrastructure too. We've had bridges up in Scotland. In fact, quite a few up in Scotland. There's been some significant interest in the coating technology due to the fact that the environment up there is that much more aggressive. Coating systems are challenged in a way that they wouldn't be quite so much in the south of the country, and they're kind of always looking for paint technology that's one step ahead of that's being currently used. So a good spread of projects across the whole region, with product being used in Europe as well, where the actual build is essentially for a bridge in the UK, but being manufactured and painted in Europe. So some good coverage with fluoropolymer. And even within bridges, there's scope to kind of diversify. There's the introduction of the FRP bridges. I don't know whether there's something that are gaining traction your way, but certainly over here, the FRP bridges have obviously got a lot of benefit, particularly good on the short span bridges. But the fact that they don't degenerate or corrode makes them a very attractive option. The introduction of FRP bridges in the UK has been a kind of slow progression. A lot of fluoropolymer has been used over the last few years on projects in Australia, where it seems to have gained traction a little bit quicker. A company over there who are engaged in the production of FRP extrusion have partnered with A&I Coatings for the application of the fluoropolymer product to the FRP, and utilised not only in bridge structures but lampposts and pontoons and everything FRP. The FRP has obviously got a number of particular benefits around the fact that it won't corrode. It's also very lightweight in terms of the actual engineering of it. There's less energy required. The system, as tried and tested in Australia, relies on the FRP being simply wiped down with a solvent, followed by the application of one coat of fluoropolymer. So a very, very simple, effective means. Yeah, effective means of providing that long life colour and gloss retention to the FRP structure. The way it's being utilised here within Network Rail is to work around a modular system. So the Network Rail stations are of typical kind of layout, and the FRP bridge design is in sections which can be multiplied out to the requirements of the specific station. Yeah, so the FRP bridges will be built in sections, and depending on the size of the station and the spans involved, the sections can be sent to site for quick and easily assembly, pre-finished to minimise the downtime and access that might otherwise be required with a conventional build bridge. And we've got one that's been designed called the Legacy Bridge by Tazica, which is being supplied for Network Rail projects. They're utilising the FRP structural element, which in itself hasn't got particularly good resistance to UV. But when using that substrate or that material and overcoating it with fluoropolymer, you get this incredible blend of benefits between something that's never going to corrode and never going to fade. You got this bridge which is designed for 120 years and will last 120 years with pretty much no maintenance. So that's another excellent area for collaboration with the manufacturers of FRP structures. The fluoropolymer in conjunction with FRP also gives a very good, gives a very fire resistant structure as well. Some independent testing, um, which has proved that. And then beyond bridges, there's facades. Obviously, a lot of your product, I guess, goes into powder coat, which is used on facades, but there's very little in terms of wet paint available for upgrading a facade finish or for doing that changing colour where a company wants to make a shift to their corporate colour. At the moment, they'd be applying probably a polyurethane over the top of a fluoropolymer powder, which is sacrilege.
Yeah, that doesn't sound quite the thing there. There's actually quite a market here in the U.S. for repainting on the architectural side, and it's not only on the facades area, but also things like metal roofing and things like that. Yeah, a metal roof may have been painted with another fluoropolymer in the factory, a factory applied fluoropolymer. And of course, over time, they start to, the coating starts to degrade and wear, and they're repainting those to keep the fluoropolymer level of protection. They're now repainting those roofs and those facades with the Lumiflon based coatings.
Mm. Yeah, well, there's another opportunity then.
Absolutely, yeah, yeah. We think,
Yeah,
yeah. On the industrial side, our focus, of course, is on bridges as well. We think
yeah.
that's a market that is relatively untapped over here, and
Mm,
we've been fortunate. We're starting to get some large projects now that are being done with the Lumiflon coatings over here, and of course on bridges in Japan and China and Vietnam and places like that, especially in Japan. These coatings have been in use for almost 40 years now.
mm,
And we have some wonderful information about gloss and color retention on some of these projects over that time period. So, and of course, the gloss and color retention is outstanding. With it, you can't match it anywhere. So,
no, no, for sure. And you mentioned about people using a product which is perhaps unknown to the market and the kind of uncertainty around that. We've done a couple of trials now, going back in 2019, on one of the significant bridges up in Scotland, where the fluoropolymer was applied alongside some of the traditional coating systems. And beginning the turn of this year, we had some incredible independent test reports come through comparing the performance of those different systems, where the fluoropolymer was showing a distinct cut above the rest, to the extent that that same bridge structure is now undergoing a more significant area of repair and repaint with the use of fluoropolymer. So yeah, I think as time goes on and there's more of it in the field, and there's more of a kind of UK orientated set of data to underpin the claims we're making, then it will be a kind of exponential growth.
Great. Yeah, I think it's very helpful. The more examples you have, the better you are in the market. We have a one of the states over here actually has undertaken a program similar to that. They started it probably 5 years ago, 4 or 5 years ago, and they put coated panels out on bridges. They put all the different coating types they use, and then
Yes,
they did a lot of accelerated testing with an outside consultant. And their results indicate that the fluoropolymer outperforms any of the other competitive materials they looked at. And they're looking at including the fluoropolymer in their on their qualified products list, which is the real key, I think, to success in a lot of these market areas. Is
absolutely. Yes.
getting into
Yeah.
the standard and getting into the specification.
Yeah.
So, what issues and constraints on the environmental side, governmental and environmental side, are you seeing in the markets you're in?
I guess the most significant one that comes up um, is around PFAS or forever chemicals, as it's referred to. That comes up a fair bit as fluoropolymer comes under the PFAS umbrella heading in the broad sense. Um, and I firmly believe that the consideration of PFAS is a right. Is there are elements of PFAS which are very damaging, have a very damaging effect on the environment, and these certainly need to be reduced and restricted. But the PFOA and the PFOS elements, which are particularly concerning to the environment, whereby they're soluble in water and they're bioaccumulative, just don't apply to the fluoropolymer coatings. Um, Certainly within the formulations that we're using based on the Lumiflon, they're not water soluble, they're not bioavailable, they're not bioaccumulative. And there's been some interesting developments over here. The HSE did a formal analysis of PFAS in March 23, so early this year, wherein they actually acknowledged the benefits of fluoropolymer technology. And fluoropolymer products have actually been removed from any potential ban um, under PFAS. Yeah, so the coating is REACH compliant, and recently actually received certification that it's suitable for use in drinking water tanks. So as much as it's kind of raised as an issue, um, I guess there's players in the market who've got they've got a they're serving a chunk of this market um, with product that's reapplied every 20 years. Um, probably see fluoropolymer as a bit of a threat and pull the PFAS card out just to maybe put people off. But what we're presenting and promoting is certainly when you consider that to raise an environmental concern um, on a product that only has to be applied um, twice in a lifetime, as opposed to a polyurethane film that has to be applied multiple times, then you know fluoropolymer is the concern around environmental concern around fluoropolymer is massively outweighed by the environmental benefit associated with low maintenance
Right,
and long life.
right. Yeah, they call them forever chemicals, and that's actually part of the benefit of a
Sure.
product like
Yes.
Lumiflon is that it does last a long time, so you minimize these other environmental considerations along the way.
Yeah. I mean, the only other thing that crops up obviously is around isocyanates,
Hmm.
which is relates to the curing component of the coating, um, which of course is used in polyurethane as much as it's used in fluoropolymer. So again, another recent update in the HSE regulation here in the UK is that that products containing a greater proportion than 0.1% of isocyanate requires the applicator to undergo training.
Okay.
Um, but it's fair to say that the fluoropolymer actually um, is lower than that threshold. And as much as we always recommend safe practice and training where it's needed, it doesn't actually require it.
Ah,
Whereas a lot of the polyurethanes out there do. So again, as much as it's raised sometimes as a negative point, the actual level of isocyanate in the fluoropolymer coatings that are produced by A&I are very low in terms of the threshold.
okay. Um, who who controls the specifications for coatings in your market?
That's an interesting one. I mean, the specifications typically are written by an engineer or a designer that's engaged to actually draw up a bridge, um, or put together the refurbishment works on a bridge. But in terms of who's actually controlling them, it's fair to say that the in the UK you've got Network Rail, and they own and they're responsible for the whole of the rail infrastructure network, and they have a set of paint specifications within a manual, and anyone working on a Network Rail project has got to adhere to the generic types within that manual. Um, on the other side, you've got National Highways. They only actually own a relatively small percentage of the bridges in the UK, but they've gone to great lengths to create this manual of coatings, preferred coatings that are used on their bridge structures, which essentially the local councils um, and privately owned bridges tend to follow that same follow the same specifications set out by national highways. They're not exactly obliged to, but they just recognise that
Sure.
as the tried and tested system. So for us, it was very, very important that we got approvals from national highways and Network Rail. A very long, drawn out process, a lot of testing, some very, very aggressive testing in place. Coatings go for this testing, and they don't always get through. The fluoropolymer obviously passed the test, and we've got the certification, which means now that engineers and designers are at liberty to specify the fluoropolymer product,
Right.
as much as they couldn't control its introduction to the market. That was kind of controlled by National Highways and Network Rail. Um, the specifiers are now kind of they're the ones who are seeing the environmental benefit,
Right.
the financial benefit, that whole benefit around the full life cycle, and they're the ones who are kind of getting it written into the specifications. They're the ones who are kind of obligation to be doing the best for the client in terms of reducing the ongoing maintenance costs and reducing environmental impact. So it's very well received. There's been so little change in paint technology in the last goodness knows how many years that this has come along as a kind of um, a dramatic shift, if you like. This is not a product which is just marginally better
Right.
than the traditional coatings. This is a product that it's a whole heap better, and there's enough data um, from other parts of the world to underpin the claims and provide that assurance in relation to its performance.
Okay. Yeah. I wish we I wish we had that over here. We have we we have 50 states and thousands
Right.
of cities and counties, and we don't
Yeah.
have an agency like that where a lot of people. I think they're trying to do that. There's a program over here called NTPEP, which is the National Transportation Product Evaluation Program. And what they do is they develop a series of standardized tests for various materials, including coating systems. and they
Right.
use an outside consultant to do the testing. And if you pass all the tests, you are on an approved list. And what's
Hmm.
happened is probably in 25 of the states are using this now as their standard. That's as close as we get to it.
Yeah.
But yeah, so I, I wish we had that. I don't have enough people to talk to all those different agencies, so it's a little difficult for us.
Yeah. Sure. Yeah.
And Network Rail is also national, is over there. Is that right?
It is. That's right.
Okay,
Yes. Yeah. Yeah.
okay. And just one thing about the importance of the specifications is that what we found over here, and I believe it's true there as well, is that the specs are so important because you want fluoropolymers competing with other fluoropolymers. If you have a standard that says you can use either a urethane or a fluoropolymer, at least in the U.S., the contractor makes a lot of those decisions over what system they will use, right? And if they can make more money using the polyurethane, they'll do that. And that's why over here, at least, getting on their qualified products list is very important for us over here.
Yeah. Yeah. Well, we try and when we're approaching market, we started with the had to start really at the top there with the national highways and network rail as the asset owners, and then as we worked through the kind of process of a project, we then were doing CPDs with the architects and the designers. It was then very important to engage with the councils. Um, they essentially are the entity that's responsible for the ongoing maintenance and care of that bridge. So it's very important to get their kind of interest and understanding in relation to the technology, and then of course finally the other key element was the contractors, because as you say, they themselves see no benefit in using fluoropolymer. They don't enjoy any benefit at all in the use of fluoropolymer. So for them to apply the same old product they apply all day, every day, which they've got a ton load in the shed already, is the easy option. So we had to kind of close that one off as well to make sure that all the way through the process, from the very outset to the job being done, that everyone was on the same page. And reality, once people see the reasoning behind it, they've got to be pretty anti-environmental, anti-carbon to not really think, well, let's embrace this. And it's working in other parts of the world, as much as it's kind of perceived as as new technology over here. It's not new. Um, it's okay. It's fresh. It's fresh technology for the UK, but the beauty of it is, this has been tried and tested in more aggressive parts of the world than the UK. So if it works there, let's get it working here.
Well, very good, Mark. I thank you for spending some time with us. I appreciate it, and I wish you guys the best and everything. Please keep us informed of what you're up to, and if you ever get over here, you're welcome to visit our headquarters and lab in Exton, Pennsylvania.
That's absolutely brilliant. Thanks, Win. Um, we're all obviously always glad to hear of any further developments you have within the fluoropolymer offering, Lumiflon offering. In the meantime, we're going to be pursuing the market in the UK. There's scope within Europe for sure. Um, there's just so many bridges that would benefit from the protection of a paint system incorporating fluoropolymer. So, thank you very much for your time. It's been good.
We appreciate that, Mark. Thank you so much.
Thank you.
Thank you for listening to our podcast, In the Mix. If you enjoyed this episode and you'd like to hear more, be sure to subscribe. To catch all the latest from Lumiflon, you can visit our website at lumiflonusa.com or follow us on Instagram, Twitter and LinkedIn at Lumiflon USA. Thanks again. See you next time.